to face that challenge that the new programming languages are coming every day, the idea is to develop the programming languages in a way that there's a cohesion between them. That means there's a sequence of evolvement among them. So if you learn one programming language, it will help you to learn the other programming language. Okay. Now that actually related to the architecture of the computer. So first of all, as we're talking about at the beginning of the course, that we had a von Neumann architecture where there are only three criterias. Okay, that whenever you have a program to run, the data and the programs are stored into the memory. Then the memory is separated from the CPU. So every time you have instructions to execute, the instructions are fetched from the memory. Okay, the instructions and the data are piped from the memory to the CPU. So that is how the von Neumann architecture work. And this is very basic for in the imperative languages. Okay, now you might think that, sir, this approach is not that good. Okay, because I have to fetch data from the CPU to the memory to the CPU. You might want to design your own architecture. Okay, for example, you have said, okay, sir, this is not a good architecture, let's just design a new architecture. Okay, where what I will do, I will combine CPU plus memory together. In that case, I don't have to fetch the data from the CPU, sorry, from the memory. Okay, the von Neumann architecture, what it does, it has different components. Okay, so it has different components. So what we do, we fetch this is, let's assume this is CPU and this is memory. So we have to transfer the data from CPU to the memory. Then you thought that, no, sir, this is not a good approach. Okay, because too much time get wasted. I will design my new architecture where I will combine the CPU and the memory. In that case, the data will be instantly executed. Now, what will be the advantage or disadvantage? Okay, so the thing is that the developers, the system developers and those engineers or scientists who work with this, they actually try all possible scenarios. Okay, and let me tell you one disadvantage that is very clear. If you combine CPU and memory, you have to make sure that both of them are functioning in a way not only in terms of speed but in terms of reliability. So for example, you know, the CPU are designed by transistors. Okay, we have talked about this, but memory, that's a different thing. The memory is less expensive, CPU is much expensive. So if you combine these two, okay, this block of hardware, it has to be able to do the job of memory and CPU. So it has to be made by in a component that can do the both, that can execute, that can store, and it will drive the cost higher. So whenever there's a new technology developed, the cost is a very driving force. You know that how? Just think about the mobile phones you have. Everyone wants the best possible mobile phone with a given price range. They are not concerned with how the architecture is being made. Okay, so what the scientists do, okay, they actually try all possible architecture combinations that you can have, and from there they develop the best one. And that's why we have the von Neumann computers. Okay, so again, for the last time, the current architectures that the von Neumann architecture we have three steps. One, the data is stored somewhere else. Whenever it has to be executed, the data is programs are piped into the CPU. That's it. Now, over the time, the programming languages evolved from very simple programs to add a number from today's programs. Okay, so at 1950s and 1960s, the challenge was to make sure the computer can do something. Okay, because previously it was all about the calculations. Okay, so they focused on simple applications, and they also had to worry about the machine efficiency. Okay, because if you know, I think all of you know that previously the computers were huge. They used to take a lot of amount of processing power, okay, and electricity. Okay, one computer that can add only 10 megabyte of data, okay, that was on the size of a room, huge room. Okay, then in 1970s, with the evolvement of the technologies, with the second generation computer, the hardware cost decreased, the programmers cost also increased, because now we have to write large programs for more complicated applications. By this 1970 time, people actually put human at the moon. Okay, and there's a video that I saw that the person, the programmer who developed the program for the moon shuttle, okay, the programs were almost like three how, what is the word, yeah, uh, 3 million lines. Okay, that is 1 million is 10 lakhs, so you can understand how long the program were. Then it was very the programs were large and it was very complex to handle these programs, and also we had to solve more complex problems related to physics. Okay, just think about if you want to go to the moon and you have a computer for that, how complex the operations are. Okay, all of you have a basic idea about how physics work. And then what happened that by that time the designers, the scientists, they were more focused on a programming language that is more structured so that we can handle these huge programs easily. Okay, and then also there's another problems, that is sometimes the top down designs and the bottom up designs were developed. So in both cases there have been some pros and cons. The top down is design means the you will design start the program from the basic approach, that you will think about what possibly can be done, and then you will start writing the program. And the bottom up approach means you will start from the last part, you will start by module, and after you will connect all the modules to make the whole program. So both actually work, both have some advantages and disadvantages. I'm not going to into that. That is a discussion for the system analysis course. Then after late 1970s, there were some technological changes. You don't have to memorize any of this. This is just for your idea. Okay. And after that, the most common one that we still using in the 1980s, the concept of object-oriented programming came. And after the object-oriented programming, the idea we have inheritance, data abstractions, dynamic method binding. All of you are familiar with these terms. Now, up to this day, we are still using the concept of object-oriented programming. But even though the programming languages had a sequence of evolution, okay, there are actually different categories of programming language. Some of the programming language as imperative programming language, such as the C programming language, okay, where we depend on the core variables, then assignment statements, okay, loops, iterations, so on. Pascal is also a similar programming language. Then there are some other functional programming language, that is Lisp, Scheme. Okay, so we will learn Lisp in the next chapter. You will see that how Lisp executes and works. And then we have the logic based programming language, okay, that is the Prolog, okay, that we use for artificial intelligence. Okay, then we have object oriented programming language, that is C++, Java. Okay, and then we have the markup programming language, that is XHTML, XML, and some other languages that we use for the web documents. Whenever I think you know that, but whenever you develop a website, there are three type of documents. One is called static documents that are always fixed. It doesn't matter who go to the website, they will always see the same thing. Another type of document is called dynamic document. Another type of document is called active document. Now the difference between dynamic active is a long discussion, but just tell me, well, let me tell you one thing. In one active document, in the dynamic document, we use an program that is called Java applet. Okay, so the difference is one program runs at the server side and another program runs at the client side. That means whenever you go to the browser, one program runs at the server and then gives you the result. Another program, just think about the Facebook. Whenever you log into the Facebook, it checks your login informations and then understand that, okay, this is the person, so I should send him these informations. So your news feed is getting sent. Okay, so that means the processing is done and then they send you the information. Another is occurs on the client side. Okay, so we use CGI, Common Gateway Interface, and Java applet for this. Don't get confused CGI with the graphics CGI. That's a different thing. This is called Common Gateway Interface, which is a collection of rules. Anyway, I'm not going to the details. This is a discussion for the networking course, but just to put you an idea, so there are different categories of programming language, each have their own challenges. Okay, and for different challenges, we have different programming languages which are better. So if you want to develop a website using C programming language, it is not impossible, but it will be much difficult than XHTML or PHP or the other programming languages. That's it. Finally, the one thing that we'll learn today, that is machine language of a computer. So we know that whenever you use a programming language, like such as higher level languages, C, C++, Java, okay, these programming languages are not understood by the computer. Computer only understands zeros and ones. So we can say that the computer understand the machine language, but the problem is it's difficult for human. So that's why we use the higher level languages. So whenever you write a program, the computer has to compile the program and translate it to the machine language, and that's where the operating system comes in. So you have already done the operating system course, so you know the what the operating system does. In short, the operating system manage the system resources. It does the input output operations. It manages all the files. Okay, then there are some text or program editors in well where you can write the programs, and then the variety of other commonly needed functions such as your um, think about your graphics functions. Okay, that actually you see everything. Previously computers in 1980s, if you just search in the internet, you will see that previous computers were all text based. There was no graphical user interface. But nowadays we can't think of a computer which don't have the graphical user interface, because we know that everything, mobile phones to everything we use, is depends on the graphical user interface. That means we can see that my computer, then we click there. Previously you had to type my computer and then you have to go there. Anyway, so we know what is operating system. It works as an intermediary. It manages everything, okay, from system resources, input output, file management, and takes programs, so on. Okay, so we'll talk about different implementation in the next class.